So yesterday, as we started talking about classes and objects. So an object, again, is just a self-contained unit that has properties, method, and other members in it. And you can see here's our property. This one example doesn't have any methods in it, but we do have methods in these. So like this public override string, that's a method there. This calc number of gallons, that's a method. So you can have methods. We've got read-only properties set in here. So just a self-contained unit that has properties, methods, and other members. A class contains the code that defines the members of an object. So this class just holds data that our object's going to end up using. And then an object is an instance of a class. An instance, again, is when a computer system creates a new context based on pre-existing model or scheme. So we have the pre-existing model or scheme here in our class. And then our object is just an instance of it. So we create the new object. In the process to create an object is called instantiation. So again, when we see this new keyword here, we're creating a new object, so we're instantiating an object. So if you hear that terminology, that's what you're going to be thinking about or looking at, is this new keyword and then calling your object after that new keyword. And then we have what they call encapsulation, and that's kind of what we've been talking about with all this public and private stuff. Encapsulation is one of the fundamental concepts of object-oriented programming. Lets you control the data and operations within the class that are exposed to other classes, so hence the public and the private stuff we've been using. What's public allow?
Other classes to use it.
That's right, other classes to use our object or classes, and private,
Is only within that class.
yes, private is only within that class. There are some other ones, we don't really use them in here. There's like static, and there's a couple other ones, but we just don't use them in here. The data of a class is typically encapsulated within a class using data hiding. So this private here is what they consider data hiding. So it keeps it within this class, and it keeps it from being seen by other classes and that. So if you hear data hiding, that's all it's really telling you, is that because it's private, it can only be used in this class, so it kind of hides it from the other classes, other parts of the code and stuff like that. So if you hear data hiding, that's kind of what they're talking about. Most classes, you'll just create, what we'll have is just properties, methods, and constructors. That's pretty much what we've been doing so far, is just our constructor is there, properties are here, and like I said, this one doesn't have a method, but the other one does. So for the most part, that's all we'll be doing with these classes, is putting properties, methods, and constructors in them. If you end up looking at page 379 in your book, that kind of gives you a good breakdown on what a class looks like and the different parts of a class. So if you're kind of confused on this or questioning it, I would look at page 379 in your book. I think it's 379. Yeah, I might have been looking at an older version last night, but
Yeah, you're good.
379?
Yeah.
Yeah.
Well, 378, 379.
Yeah, so yeah, 379 gives you a diagram kind of on how it breaks down. So it's nice. If you're kind of confused on this, go look at page 379, and you can use that diagram as much as you need to kind of figure out what these parts are. If, as I lecture, do these code alongs, if you're kind of getting lost, just kind of pull that out, and you can kind of look at the stuff and see what's going on with it. The object, like I said, is instantiated. A constructor is executed to initialize the data and make up the object. So when we go to our code and we use that new, whatever we're calling at the time, this here's that array called classified add, that new keyword, and then the name of the object afterwards just means that's when we're instantiating it, that's when we're going to start using it. Data that makes up the object. So this category, this num words, and the price in that, that's sometimes referred to as the object state. I know it's kind of weird to say it like that, but once you have instantiated, the state of the object can change. So if you hear them say the object state, just know they're talking about the data inside of an object. Once it's been instantiated, once you do that new and call your class or your object inside your code, that instantiates it, that tells it it's going to have a chance to be changed. The state of the object changes whenever you change the value on the object's properties or public fields. So when we go in here and set these values here, that's changing the object state there. We changed the default for category from an empty string or null, technically it's a null value, to used Honda. We changed the object state at that point. We changed the data that it started out with. State can also change when you call a method that affects the data stored with an object. So when we call some of these, keep going there for some reason, when we call these methods down here and it calculates our wall area and stuff like that and calculates our number of gallons, and we change the num gallons down here, that's also changing the object state. So when you hear somebody say the object state's changed, that's all they're talking about is some of the data inside the object's changed. So an object initializer lets you create an instance of an object and assign values to the object in a single statement. So an example of that real quick would be something like this. Let me bring it up here. I'm going to throw it in here. It's going to cause an error, but I just kind of want to show you how it works. So we have our class, we have our getters and setters, and we have our actual program here. So when you initialize this,
Does that say student what?
student STD, it doesn't matter. It's just an example. I'm not, the code means nothing. I'm just trying to give you an example of how an object initializer lets you create an instance of an object and assign values to that object in a single statement. So we initialize it, we instantiate it, and then we assign it the values that we want to assign it. So you can do that in your code for an object, and we do it on one of these examples I'll end up showing you.
So that's your main method right there?
Technically, yeah. So if we were running a console app,
Right.
that would be running out of a console app since it's not using the form or anything like that.
So like it's a method within a method, basically. It's kind of like
The static void main part.
say my hand.
Yeah, what's the static again?
Static is just the way it's called. We don't use it much in this class, so we probably won't touch much on it. I think if you actually read through the chapter, they talk about creating static modifiers and stuff like that, but we don't use them. We're not going to go over them much in here. But the whole purpose of this was just to show about object initialization, doing initializer, and assigning values to your object. That's all it is. I'm not worried about where it's run from in here or what the name of the class or object is. It's just to show that you can initialize an object, instantiate it, and then assign values to it. That's all this purpose was here.
So like a class, like I said, it was a method, like a method within a method. So basically, let's just say my hand is the method.
That main method is a class, yep, technically.
This is a method.
Or-
and this hand is a class. Goes over.
It's inside it actually, so you'd have your class and your method would be inside of it.
That's fine.
Yeah, and then as you need that method, it just pulls the method out and uses it where it's needed at.
So wait, what, if you're calling class and there's multiple methods in the class, how do you pull out the method you want?
Well, like right here, when we did the painting demo yesterday,
Is this in the class?
yes, this is all in the class. Here's our public class called Room. You can see my room.cs file. CS stands for C#. So that's my class file there. We set up two methods down here called that calc number of gallons and calc wall area. So then when we run this room, when we use the object, here, and it runs through this room object, it goes and runs our method for us, so then it can calculate our wall area and our number of gallons. And then as we print them out to the screen, you can see it gets the values for the number of gallons in the wall area down there when we print it out and show the values of it.
So, scroll up. So wait, where are we calling the class?
The class we define here in the class file.
Yeah, so how do you know which instance fields? Will the rubric tell us like what fields?
Yes, and then as you start coding on your own, actually the second lab does not tell you what you need for instance fields, but as you're doing it, you can see all the data that it needs to take in and put out, so you should be able to figure out the instance fields from looking at the actual lab demo printout for it.
So the width, length, and height, you have commas. Is that just your personal preference?
No, we needed to pass that width, length, and height in to get the area for the walls.
Room.
And room just happens to be the name of the class we created. You can name your classes anything you want. It's just an identifier kind of a thing. But you want to name it something to do with what you're working on. So if you are painting this room like we're doing and setting up a class for it, you don't want to call it farmhouse or anything like that because it has nothing to do with your code or anything like that. So
It's a little confusing.
does that make sense? It's just an identifier. You usually name it something that relates to what you're coding out.
I might need help later.
All right. So then a class defines a reference type, and that's what I said when we call these over here. Let me get a better example up. We call these here our array. It's a reference type is what it actually is. It's not an access modifier. It's not a data type. It's just a reference type is what they call it. And the reasons it's a reference type is because we're referencing that class. We go back and use the class. We go back and reference the class and then use that object.
Why did you, I'm sorry.
That's all right. Use the object out of that class. Question, Gavin?
Yeah, why did, the private decimal price, go back to,
My class.
why'd you, comment that out again? You said because we don't need it, or what was it yesterday?
Yeah, we used a read only and we did it with a property. And so we don't actually use this price instance field, this price, the underscore price.
Yeah.
We don't actually use that anywhere here in our code. So because we created this property, this price property,
Right.
and we don't use the instance field, I could go ahead and copy it out since we didn't technically need it.
I'm just trying to figure out my problem, because it still says that my class says could not be found, are you missing, or using a directive or assembly reference?
I'll check it after this, and it might, like I said, your curly bracket might be in the wrong place or something like that.
Okay.
So a class defines a reference type. That means the variable that's used to access an object instantiated from a class contains the address of the object, not the actual object. That's just something for memory purposes. How to code fields, and these fields are these instance fields up here. A variable defined at the class level within a class is called a field. In a class at the class level is a field, and we can tell they are because of that underscore there. It shows that these are instance fields. So a private access miner, again, just prevents other classes from accessing the field. Can only be accessed from within the class. If your property simply sets or returns a value, you can use an auto-implemented property, and we'll get into those today. That's the word I was looking for earlier. I couldn't think of as an auto-implemented property. They're in the background running kind of like our free constructor up here, but as we code through them, we'll end up showing them and then use them to get and set. But since we're not really changing data and only kind of pulling data and pushing it out, we can use these access modifiers. Automatically creates a field behind the scenes to store property value. And so technically they would be here if we needed them, but we're going to actually code them out so you can see them being used. When you need to process a value before you set or return it, you can code the field yourself. Then you can work with that field in the code for the getter and setter, so you can modify it up here at times if you need to, and then use it down in your getter and setter. A lot of times you'll just be coding them in the getter and setter. It's common to use the same name for the property and for the field. So if we call, like you see here, we're going to call it price. But our property here is called price, like number of words, num words. Our field name is underscore num words. Our property is also called num words. So you want to keep your property name category the same as your underscore field name category. Then you can work with that field in the code for the getter and setter. It makes it a little bit easier. They begin with the uppercase letter and field names with the lowercase letter. So you can see our field is lowercase c, lowercase n. But our property name starts with a capital C, capital N. And they are Pascal case, so every follow-on word, the first letter is capitalized, the rest are lowercase. So provide other classes with a method. You got to declare it as public. We've already talked about that many a times. To prevent other classes, you just make it private. The name of the method combined with its parameters form the method signature. That's common knowledge. We've been doing that since we started doing methods. And then if a method simply returns an expression or executes a single statement, you can code it as an expression-bodied method. We talked about that briefly. That's kind of like not having to always put these squigglies behind it when you do a method, if it's just like one-line method. Let me bring the other example up. So like, if this count gallons was something small, all we'd have to do is put like one line of code under it to run it. I don't recommend doing that. I would always use the squigglies. Just get in a good habit of doing that. As you put a lot of code in there and you end up forgetting your squigglies, you're going to have all kinds of issues with it. To code an expression bodied method, you can code the method signature followed by the lambda operator. And that's what we're doing in one of these examples. I think it's on the other one. Using that lambda there just to do it on that one line for that get and the set. That way you don't have to put all the squigglies and stuff in there like we did on the example right here with the squigglies. Have one line, you can put it with that lambda and just print it out like that. Coding constructors, and again, that constructor, it's there running in the background, so you don't have to code it, but I would get in the habit of coding it. It's just good practice to do it, and then when you start creating overloaded constructors, you got the base one there, and then you can add on to them. The name of the constructor must be the same name as the class, so you can see our constructor is called classified ads. That's the name of our class, is classified ads. Must be declared with the public access modifier, and it can't specifically return a type. So we give it public. There's no return data type or anything like that. It has to be public so it can be used outside of this class. If not, you won't be able to use this class at all, or the object that you're creating in the class. To code a constructor that has parameters, code a data type and name for each parameter within the parentheses that follows the class name. I think we did that in this painting demo. So you can see here our access modifier is public. The name of our constructor is room, same as our class. And then we have our parameters that we're passing in, data type, variable name, data type, variable name, so on and so on. That's how you overload a constructor using parameters. If a constructor doesn't set a property and the property wasn't initialized when it was declared, the property will be assigned a default value as shown. I thought in one of my demos, I'll have to look back through real quick and see if I can find it. But a lot of these default to a certain things, like a string will default to a null value, an int defaults to a 0, a boolean defaults to a false. So if you don't give it a value or declare it anywhere in your code up here, it's going to automatically set it for you. So our width, length, and height would all be set to zeros. Wall area 0, number of gallons 0 because they're integers. If they are strings, it'd be a null value is what you'd get. And as you're working on this, you'll end up getting a lot of null values will start popping into your code because of this. That's where debugging comes in handy to find out where that null value is coming from or why you're getting it and why you may have to set it. Like I said, when I worked for the Department of Defense, they ran a program called Fortify that checked to make sure no null values were getting passed and they were all getting caught. So eventually you'll do null checks to see, make sure it's not passing a null value in, and if it does, you handle it in a certain way. Don't remember if our labs get into it, maybe with the try-catch stuff that we start doing. I don't remember off the top of my head right now, though. And then if a constructor contains a single statement, you can code it as an expression-bodied constructor using that lambda operator again. I don't think we do much of it in this class, but it would just be that room with the equal greater than sign to make the arrow. And then you could just put your one property there. Coding methods. Let me go back to the method part of it. Coding methods. The name of the method combined with its parameters for the method's signature. We know that. We've been working with methods for the last couple weeks now. More than one method can use the same name, but each method must have a unique signature, and that's when we were talking overloading the methods from the previous chapter. Methods with the same name but different signatures are overloaded. It's common to use overloaded methods to provide two or more versions of a method that work with different data types or that supply default values for omitted parameters. When you type a method name followed by a left parenthesis, the IntelliSense feature adds the right parentheses. We know that kind of stuff. Since constructors are method, you can overload them too, and we've talked about that. We're overloading our constructor here because, like we said, we get that free default one here, but then if we want to pass parameters through it, we overloaded it right away just by putting a parameter in there. So signature of the constructor is the name of the class, again combined with the parameter list. Each constructor must have a unique signature. Putting the parameter list in, that's the unique signature. So that kind of briefly goes back over what we were talking about and working with yesterday. I know I went over some of this pretty quick, but we worked with it yesterday. All this is in your book. If you need to, read your book again. The descriptions part, I think, is what it is. Let me look real quick. Yeah, at the end of certain, I wouldn't say chapters, but certain topics in the book, there's a description part at the end of each one. You can find all this information in those descriptions and relate them back to that topic that you were looking at in the book. That's why I said that page 379, because that's where all these come from, is those descriptions from the book. So give me a minute, let me get set up, and we'll do some more code alongs and that kind of stuff, and then I'll turn you loose on labs here in a few minutes or a little bit. Picking up where we left off yesterday, looking at the painting demo one we were doing. So we were using an array to access the room to get everything to print out. And now we're going to switch it over to using a list. Like I said, when we start working with databases and that, you'll end up using a list to return everything. You don't have to worry about size. It dynamically increases. So I think it sets it at like 3. If it goes over 3, it doubles to 6. If it goes over 6, it'll double to 12, and so on and so on. And it can hold quite a bit of data in it as it returns from the database. So to set up a list, all we do, and we talked about this when we were doing the arrays, is you declare it as being a list, and you use the angle bracket there, as you can see. And then we call our class inside there. This is normally where the data type goes. So if an example up here, if we want a list of integers, we can do integers. We call the variable, the identifier for our list is my numbers. And then to add numbers into our list, you just do .add and put the values in there. And so I am in our actual form.
That list you made down below? Like, yeah, right there.
Yep.
I don't think you saw that.
So I'll get to that here in a second then.
Changes.
Yep, I'll get that here in a second.
Because I'm still on like the my home screen.
Okay. So we have our list, create our list, we declare it as a list type instead of an array. As you can see here, we use the array here. Well, now we're using list, and then right after the list you use the angle bracket. You put your data type in there depending on what you're using it for. Since we're going to be using it with our classes, we put our class name inside the angle brackets, and then we give it a identifier name here using the integer example. And this is just an example, we're not using this for anything. I'm going to get rid of it here in a minute. So we just call it my numbers, and again we instantiate it by using that new keyword, our list, and the data type in our list. And because it's a constructor that we're using, we had to put our parenthesis there. And then we just call our variable name, and like I said, you can do .add to add that 100. They have a my numbers.remove. We'll remove, so that would remove that value of 20 that we just put on the end there. It would remove it. I think that's mostly what we'll use lists for, is just adding and removing values for our lists. And then you do a for loop through them just like you would an array, and you use the .count. You don't use a length on the list, we use a .count because it counts how many items are in it, not The length is for the array, counts how many things are in the array, the length of the array. The list, we do a dot count, and it counts the number of items in our list. So that's one of the bigger differences from arrays and lists. I'm going to go ahead and get rid of this. So to create your list for these rooms that we're doing, all you do is create a list. So if you want to type that in, angle bracket room, and then I just call it our rooms. Give it a new list of rooms, and you can just go down in this array that we had, and you can copy all that and just paste it up in here.
You have different numbers.
So paste it in here, just paste it. You put whatever numbers in there that you want. Because we have one set up that it's going to take our parameters off our form. On our form we put that width, length, and height in there. And just like that array, we have one of them returning that width, length, and height that we enter into it. You can see down here I commented out if we want to do an add, you can do rooms. Actually, it'd be our rooms since I'd switched it over. That would add a new room to it if we wanted to add a new room. But we're not adding it on here actually, so we're not going to worry about that. But that's how you'd add another room onto it if you need to. And so you can see our list is almost exactly like our array. There's only a few differences by using that list keyword. The angle brackets, putting our class inside the angle brackets instead of setting up our reference to room with the array. We set it up with the list and then call our class from that room, our object. Use the new keyword just like we do down here for our array, and set up our list just like we do for an array. Takes the data, we do a for each, we walk through room, make sure I named it right, our rooms, and it should print out. So if I run this, hopefully everything will still print out and show like we had yesterday. If I do 100 by 200 with a 9-foot ceiling, and again there's our 200 by 100 room with a 9-foot ceiling, has 5,400 square feet, 16 gallons of paint. So you can see using a list worked exactly like our array did. There's not much of a difference to them. I would recommend starting to use a list now as much as possible after this, just because as we get closer to working with the database at the end of this semester, and as you move into Mr. OG's classroom, you'll start using a list a lot more than an array.
See the numbers real quick. They're different than last time. Just the list numbers.
On my,
Right there, you're on the, like, you're there on the list, just all those new rooms, so.
so I just changed them around so it'd show different values. You can put whatever you want to in there, as long as you have a width, a length, and a height. That's all you need. Yeah, Paul.
So, to get this straight, so like each new room with like those 3 values, that's one index of the list, right?
Yes. Yep.
So how, say you wanted to just like access that 10, how, is it like just a multi-dimensional array, like index 0 and then index 1?
Yeah, you'd call it by the index like that.
I'm trying to do that in the lab and it's telling me it can't do that.
Does it give you an error for it?
Yeah, again,
Take a look at it after the demo. So let me pause. So that's the biggest difference between using a list and an array. I would recommend, again, using the list as much as possible after this. It just makes it a lot easier. They work in the same way. So that's that one. Let me get set up and I'll do another demo here real quick, and then I'll turn you loose on labs. Alright, so this next one we're going to do a sales tax demo. And we're going to be using some auto implemented properties for this. So we're going to create a new, or add a new project. It's going to be a Windows Form application. I call it sales tax demo. Create this. We got our Windows form up. First thing we're going to do, go ahead and click on our sales tax demo project. We're going to add a class. We're going to name our class sale. Like I said, you can either put CS down here or it'll do it itself by default. And namespace sales tax demo, it's the name of our file. Project, and then we have our class, internal class sale. First thing we do is get rid of that internal and make it public. In this program, it's going to create a program named sales tax demo that declares an array of 10 sales objects. Prompt the user for data for each object and display the 10 objects. Data fields for sales objects include an inventory number, amount of sales and tax owed. But we make the tax owed a read-only property. How do we make it a read-only property?
By not returning.
By only putting a get.
Exactly. We only put the get. We don't have to put the set for it because we're not going to be changing anything in it. Tax should be calculated whenever the amount of sale is set. Assume that tax rate is 8% for the first $100 and 6% for any amount greater than $100. So first thing we're going to do is it says create data fields for sales objects include inventory number, amount of sales, and tax owed. So, of course, we'll start with our instance fields. That's what we were just talking about. And we want a private because we only want it used in this class. Data type is a string. And our field name is inventory number. We need a sales amount, so we'll also do private for that. String, oh, not string, sorry about that, decimal. Call it sales amount. And then we need a private decimal tax owed. So like I was saying earlier, with these instance fields, I'm just going to copy and paste this real quick. Instance fields are marked private by convention because this implements an object-oriented programming So when you hear OOP, that just usually means object-oriented programming. That's what C# is. That's what Java is. Called data hiding. And we talked about that a little bit earlier, just saying that it keeps the data from being seen and used by other classes. With data hiding, we provide controlled access to our data, which means we only allow who we want or what we want to see it. So again, these are our instance fields. By declaring them private, which we always want to do, it keeps them in this class. Uses what they call data hiding, which only allows them to be accessed in this class and not other ones. And it gives us controlled access to our data. So we got to create our properties. So we'll do public, since we want these used elsewhere in our code. And I'm not starting with inventory number because I'm going to show you something with that here in a minute. And again, when we do our properties, we want them to be the same as our instance fields and same name, but they start with a capital letter. Use Pascal casing. We're going to return sales amount. Our set, we're going to do some manipulation in our set here. That way we can figure out tax owed. So we'll do underscore sales amount equals value. And again, when we do our properties like this, the get will always do the return. That's set. You set the instance field to equal value when we do it this way. Yep.
Sales amount equals value. We don't need the. We can just put it in front of set, right? With the curly brackets. That would store.
Yes, if you want to do it on the same line, but we're going to add a little more code into it, so that's why I dropped it on another line. So we're going to do an if statement in here and say if value, which is what's getting passed to the sales amount, is less than or equal to 100. This is just like a normal if statement. Tax owed equals the value times 8%, 0.08, and it's a decimal, so we have to give it the M behind it to make it happy. So this is taxing that first $100 of whatever the value is by 8%. It's kind of weird how they did this, but else tax owed equals 8 plus. Hi, Robin. Minus 100 times 0.06. And Again, M's a decimal. So this is anything under 100, it's going to tax it by 8%. This is going to tax it by 8%, and then take the remaining value that's left and tax it by 6%. Like I said, this was a weird math problem. You don't see it like this very much. Usually whatever's taxed is taxed, not by a certain amount. Yep. Yep. Okay. So then it says we need a read-only property for our tax owed. So public decimal tax owed. Now if we want to, we could do the shorthand way like that. I believe we can do it that way and get it to work. If not, we may have to put it inside the curly brackets. And actually, I'm going to put it inside the curly brackets just so I don't have to worry about whether it's going to work or not. So I'll do get. I'll just do it like that. That way I know it'll work for sure. So when we use this auto implement it, and that's what we're going to do here is auto implement property and we're going to do our inventory number with the auto implemented property. So we'll do a public string inventory number, and we're going to do a get set. And that's a quick, easy way of doing those getters and setters. It's called auto implemented property. You usually use this when you don't want to do anything fancy, you don't really need to change anything, you just want to get data in and get data out. Yes. What's that? And because we're auto implementing this, when we auto implement these properties, we don't need these instant fields anymore. So if we auto implement a property and we're not going to change anything with our instance fields, we can get rid of them. So I can comment out this inventory number, and it'll still work because we have our property inventory number and it gets and sets it for us. So it kind of does this instance field in the background of it when you do it, auto implement it. And a quick way to auto implement it, I'm going to comment this out or get rid of this for 1 second, is if you start typing in prop and then do a tab, it'll set it up for you. And all you got to do is change your data type to what you need it to be. And ours is a decimal. Or no, ours was a string, I'm sorry. String, and then we just change the name on it to inventory number. And because this is a property, we capitalize it again. We don't use lowercase or the underscore for it. We capitalize it. So the only thing with these is it's uncontrolled access. We can't, it can be used anywhere. We can't tell it how to do it. And uncontrolled access is we can't put any code like this inside of it. So this technically has controlled access because we can control what we need to do, manipulate in here. How do you spell manipulate? We can change data in here. Auto implemented property is uncontrolled. We can't do anything in here. So we only use this. If we're not going to do anything fancy, I'll get it figured out here sooner or later. Just get and set data, you know, push and pull data for the most part. So it's nice if you don't have to manipulate any data or anything like that. You can use these just to get and set your data. If you need to do some calculations or figure anything out, then you got to use regular property. That way you have some controlled access of it, what we can change inside of it. We use these auto implemented properties. We can't control anything. It's what it is. Get, sets, straight up, that's it. No changing, nothing. So you can also, if you, we need that. So for instance, we could do something like this and do a public string inventory number get set public decimal, and this is if we weren't going to change anything in our code. Get set XO get set. And usually IntelliSense is pretty good and it'll populate it all for you. It'll set up all your instance fields inside of it. There it goes. So it's usually pretty good about setting it all up. I don't know why it's wanting to do extra. But usually it'll set everything up for you. It's nice and easy. You can see it puts your instance fields in here, stuff that we don't have to do. It'll do it all for us. It's all running in the background kind of a thing. But we'll get more into this. I'm not going to do it here. I'm going to take this out just because we're not going to use it like this. We're using it how we set it up down here. And you can see I got some issues just because I've got all this already declared down here and I don't need it all. Yeah, that will automatically generate it for you. So if you start coding these auto implemented properties in here, start setting up your constructor, it'll pretty much fill it in for you and code all that part out. So it is a nice time saver just because it's so basic. It doesn't really have to think much. It just populates everything real quick for you. So if you end up using those, that's just kind of a shortcut how auto populate, get you set up real quick. So now that we have our class finished for this, let's go look at our form, and we'll get this set up. So of course we're gonna get our famous button on here.
Should we make a constructor?
What's that?
Should we make a constructor?
We got that free one running in the background, but yes, we should, like I said, get in the habit of doing that. So you'll do public sale. Oops. We don't even need a semicolon behind it. So there's our constructor. It's free. It's always running in the background. Like I said, though, it is nice to get in the habit of coding that out. I'll show you an example here in a little bit after this of some Java stuff I'd worked on in the past, that how it's set up compared to the C# stuff. So there's our constructor. Go back to our form, put our button on here. We'll put a couple labels and a couple text boxes. Let me put a label on here, text box with it. We'll call this label 1, we'll call sales amount, or sale amount. Text box, sale amount. I'm going to highlight both of these, hit Control C and Control V and just make a copy of them. Now I can just move it up here. Just rename them. Call this inventory number. A little closer, and then my text box. I don't think I named my label actually. And then our button will be add sales and display. And then we want a result label down here. And we'll go with the ever popular results, LBL results. Gonna get rid of the text. So that'll be our setup for our Windows form there. Everybody good with that? I still hear some typing going on. I don't hear anybody saying no.
Wait, can I see your sales.cs page? Include. Yeah, I think I got it.
You got it.
Except for that overload.
Just the constructor, the default constructor there. Yeah, and like I said, that's running in the background. If you don't want to put that on, you don't have to, but it's nice to get in the habit of doing it. I don't think Java that it allows it to run in the background. I think Java you have to actually code it in, so that's why I say kind of get in the habit if you end up doing a Java job. So we'll go back to our form, click on our button, get it wired up, ready to code. So first thing I'm going to do is we're going to create a list to hold all the sales that we make. So I'm going to put it just under my public partial class form 1 form. Doing that for the scope. That way it's more of a global scope or a class scope as they call it. It can be used anywhere in the class. I'm just used to calling it global. I think the technical word is really class scope. And we're going to call it daily sales and a new list sales. So we're going to do a daily sales, and we're just going to do a .add. And we're going to say add a new sale. And so what we're saying here is the daily sales. Add a new object sale into our daily sales. So we're creating a new object in our daily sales list and adding it to it. And then we'll do daily sales. And we're going to use the index here. And we'll do a daily sales.count -1. And the reason we're doing this is we're using the index out of this daily sales. Count starts at 1, but our index and our arrays and our lists start at 0. So that count starts it at 1. We don't want it to start at 1. We want to start it at 0. So we're going to do count -1. And then we want to assign the value of the sales amount. So our form here should have sale, I call it sale amount, and that's why it's unhappy over here, is because I call it sale amount, not sales amount. So if I take that S off there, it should be happy now. So if you have a red squiggly, first thing I would do is check the spelling and make sure everything matches up. And you can see I had that S in there. It wasn't happy because that's not what I made my property name over here. My property name is sale amount, but I was trying to access a property called sales amount and it's not there. So, and we're going to assign it the value of our text box. So we got to convert the sales amount to a decimal, and we're just going to put our text box in there. So what we're doing here now is we created our list up here called daily sales using the sales object, or sale object, I should say. There's no S on it. So then we're going to do daily sales, the name of our list, our identifier that we use for our list. We're going to add a new sale object into it. And in that sale object, we're indexing the 0 index on it by doing this daily sales.count. And again, that count value starts at 1. Our index for our list, our index for our arrays, they all start at 0. So we're going to do count minus 1 to get that set to 0. So it would look something like this. It's kind of what we're looking at, but we're going to code it different. So it'd be something like that. And that's what we were talking about earlier, Paul, doing that like that. But we want to count, so we're going to put the count in there just to help count the number that we're putting in. And we'll do daily sales. And again, daily sale count. Minus 1. Daily sales count minus 1. So now we set the property of that sales amount up on the line above. Now what are we going to put in this, what do you think?
Inventory number?
Yep, we're going to put our inventory number in there. So then we'll do inventory number. And that inventory number is just going to equal our text box, because our inventory number, if you recall over here, is a string. Our inventory number is a string. You can see now that we're calling inventory, our reference changed from 0 to 1. And we're just going to put our text box in there. Oops. So that's going to populate the inventory number for us. And then being the list, we got to walk through this to get our values out. So we're going to do a for each. And then we'll do sale item and daily sales. And we got to print it out to the screen. And instead of doing this, we're going to use that toString method again and override it, just because you can do so much with it and put everything in there. So we'll go back to our sales class. Under our public string inventory, we're going to do a public override string toString. And again, that override just says we're going to override that toString method that somebody else created and use it the way we want to use it. So we're going to return something like, we're going to use string interpolation and do sale item info.
And what's the purpose of overriding it versus making a new one called like print string or something?
You could create a method like that if you want to, but that override, we'll be using it more and more as you're writing code and stuff like that, so it's kind of nice to get familiar with the override. And we're going to say inventory number, sale amount of. And you can see we're using the property names now in this instead of using the instance fields names like we were doing yesterday. So I guess I should have called it Salem's amount, since that's what it's actually called. Sale amount. We want sale amount to be a currency number, so we give it that :C. And a tax owed of tax owed. We want that to be currency also. And I'm going to put a new line at the end and end it. So if we go back and look at our code, I want to get rid of that item 2 string, or actually that should work fine, that item 2 string. Do we have that in here? So I just want item 2 string and not the sale amount 2 string, because we're going to print it all out in that string that we created. Why is my text not happy? I can fat finger my result. Reslut, that's not good. Now it should be happy. There we go. So the reason we put our list up here is because every time we click this button and add to it, we don't want to overwrite our list each time and start it over. So this count should keep track of the count as we go through. So let's give this a try and see what happens. Helps if I pick the right one. So we'll say sales amount $1,000. Inventory will be 1A5C. Sales item info, inventory 1A5C has a sales amount of $1,000 and tax owed is $62. So we can do 2,000. Change our inventory number to 3B, 2B or not 2B. And it changes it there. I need my plus equal sign on here to get it to show each one individually. So let me redo this real quick. I did on the at the end of our 2 string. So we'll do $1,000. Inventory is 2D 3G. Inventory 2D 3G has a sales amount 1,000. Tax owed 62. We'll do 2,000 for E5B. And it added on again. I have to go figure out and see why I did that, but that's kind of what we're looking at there for it. If I do it again, I'll probably put all 3 of them down. So I need to fix that, but you get the gist of it. What's that? My return down there for the scoot this over so you can see a little better. All right, hang on 1 second. I'll come check. Oh, I know what I need to do. I need to clear.
Yeah, I was gonna say like just.
So every time I click on this, I want to clear out my text box. So, and this will fix why it's repeating over and over again. So now if I run this, 1,000, 5T, 3E, 2,000, 1E, 2S, there we go, 3,500, six H, 7J, there we go, 100, 0R, 7Q, tax owed $8, my 8% of 100. So that's that one there, and I think you got one of them on your labs that you have to keep asking the user to enter stuff in. So that's kind of how you do it, to where you keep adding it to the list. And everybody good with that? Any questions, comments, concerns? No?
It'll take some time getting used to.
That's all this is taking time to get used to it. Practice, practice, practice.
Can you push that code out to me?